Okay, so now I want to prove that point, that if I've got two linear maps, then their composition is still a linear map. Let me be a bit more precise, because there's something that a bit wrong here. If I want to do the composition of F with G, I need, well, let's say that it starts from a set E. So first thing is that it's going to be applied to, we're just first going to apply G. So let's assume that G goes from a set E to a set F, and then F goes from F to a linear space G. Otherwise, I can't do the composition, all right? If I want to apply F to G, I must have that the domain of F is included in the codomain of G. Otherwise, I can't really do the composition. All right. So this being said, I want to show that F composed with G is linear, assuming that that F and G are themselves linear. So what does it mean? It means that F composed with G goes from set E and has image in a set G according to the chain that we established here. Okay, so we've got some kind of chain here. Right. Okay, so let's do that. So what does it mean? We want to show that for all x and y in E, for any lambda in R, I really have that the composition F with G of lambda x plus y is equal to lambda F composed with G of x plus F composed with G of y. Okay, and again, this being the question that do we have this equality, right? So let's do this. F composed with G of lambda x plus y is just going to be F applied to G of lambda x plus y. I haven't written anything very interesting here. I've just written what it means to do the composition. Sorry, that's stuff's remaining from the previous video. Okay, so now let me expand on that expression. G being linear, it's going to be lambda G of x plus G of y, as G belongs to the set of linear maps from E to F. And then we use the linearity of F itself, and it's just going to be lambda times, so that's an element of F, that's an element of F, that's a real number, so I can just directly use linearity of function F, lambda times F of G of X plus F of G of Y, as F belongs to the set of linear maps from F to G. Okay, so this is it. This is what we wanted to get. This is really lambda times F composed with G of X plus F composed with G of Y.